Hello, and welcome to Lesson 4.1. This is on page 443 of your textbook, and it's titled, Oh Yeah, Prove It. We are going to be learning about inductive and deductive reasoning in this lesson, and it's the last lesson of this course. We're going to do a little bit of the group work before we do the classwork because there's some things we need from this to be able to do the classwork. So towards the bottom of this page, they give an example of the U.S. Supreme Court. There's 9 justices, and when they enter, they do a conference handshake, so they all shake each other's hand. So what we'd like to look at is try to figure out how many handshakes are necessary, how many total handshakes. What if there were just 2 justices? So you're here and I'm here, we shake hands, we're done. We've done the handshake. So if there's 2 justices, we only need 1 handshake. We can illustrate the situation by drawing 2 dots, and they give the example there that shows them shaking hands with each other. That might seem a little silly, but the idea is to figure out how to do drawings for these. So we're going to extend that on page 444 and look at what would happen if we had 3 justices. If we had 3 justices, the first person would have to shake hands with the second person and the third person. And I kept my eraser up. Let's fix that. First person would shake hands with the second person and the third person. Now the second person, the only person they have left is the third person. So we connect them, and that tells us that there are 3 handshakes necessary. Let's do the same thing for the fourth person. Or for the four people. The first person has to shake hands with the second person, the third person, and the fourth person. When we get to the second person, all they have left is the third person and the fourth person. When we get to the third person, all they have left is the fourth person. And by this point, the fourth person has shaken hands with everybody. Count up the number of lines. How many lines did I draw? You're right, 5. So if we have 4 justices, we need 5 handshakes. Let's do the next with 5 justices. Again, start with our first person and connect them to everybody. Person 1 shakes hands with person 2, 3, 4, and 5. Person 2 only has left person 3, 4, and 5. Person 3 only has left person 4, and person 5. And by the time we get to person 4, all they have left is person 5. And person 5 is done because everyone came to them and shook their hands. How many lines did I draw this time? Count them all up. Should get 10. All right, the last one we're going to do with a drawing is 6 people, which is good because my lines tend to not be very straight. Person 1 has to shake hands with person 2, person 3, let's fix that one because it's not even connected to person 1. Person 1 connects with person 2, person 3, person 4, person 5, and person 6. Person 2 only needs to connect with person 3, person 4, person 5, and person 6. Person 3 only needs to connect with person 4, 5, and 6. Person 4 only needs to connect with person 5 and 6, and then person 5 only needs to connect with person 6, and then person 6 is done. Count up the lines. You can pause me to do that if you need to. You should get that there were 15 lines. This is an example of inductive reasoning. Inductive reasoning is the process of reaching a conclusion based on very specific examples. So we're going to try to use those examples to figure out how many handshakes we would need for 9 justices. So let's write the numbers in. We knew 2 justices was 1 handshake, 3 justices was 3 handshakes, 4 justices was 6 handshakes, 5 justices was 10 handshakes, and 6 was 15. So we'd like to see if we can pick up a pattern. Go from 1 to 3. So going from 1 to 3 added 2. When I went from 3 to 6, how many did I add? I added 3. When I went from 6 to 10, I added 4. And from 10 to 15, we added 5. Looks like we've got a pattern. I added 2, I added 3, I added 4, I added 5. So to get to 7, we'll have to add 6. So if there's 7 justices, I need 21 handshakes. And then I need to add 7. 21 plus 7 is 28. And then I need to add 8. 28 plus 8 is 36. So using inductive reasoning, we have determined that if there's 9 justices, they will have to have 36 handshakes. The other one I wanted to do from the group work together, because they use it in the classwork, is number 10. Number 10 asks us to work through an example. It says, pick any number you like. Let's do 5. 5s are fun to work with. Multiply by 8. Add 40. And you can use your calculator as much as you need to do this arithmetic. Divide by 4. Subtract 10. And then subtract your original number. My original number was 5. And look at what we get for the answer. We get the original number back. How cool is that? So this would be a great place to pause it, do it with a few other numbers, and see if that's true. So what it looks like is going to happen is that I'm always going to get my original number back. Definitely practice it, try a little bit of that. You can probably do it in your groups too, with some other numbers besides 5. Page 447 is where the classwork actually starts, and this is the part we're going to do together. They're giving us a new definition of deductive reasoning. Deductive reasoning is the process of reasoning that arrives at a conclusion based on known rules or principles. They have already defined inductive reasoning for us. Inductive reasoning is great for seeing patterns and making educated guesses about general results. So in question 10 of the group work that we just did together, we are looking at inductive reasoning. We could do tons of numbers. We could do every number we could think of. We could do it for the next hour and a half, but it doesn't prove to us that it always works, that there's not some number that will make it not work. So what we want to do is bring in a variable. So we're going to let this variable be n, and that can stand for any number in the world. So that's representing any number possible. It says start with n and multiply by 8. So that's going to give us 8n, 8 times n, but when it's a variable, you can just keep it smashed up next to it. Now add 40 to what we just got in number 1. So for number 2, we're going to write the expression 8n plus 40. All right, we're making our way through this. Next, divide the result by 4. Oh, that's a little bit tricky. So I probably want to put parentheses in it or write it as a fraction. Either will work. And the reason he's saying to be careful is because when you're dividing by 4, you have to divide both terms by 4. 8n divided by 4. 8 divided by 4 is 2, and then the n stays. 40 divided by 4 is 10. So when I simplify that division problem, I'm left with 2n plus 10. Now number 4 says subtract 10 from the result. So take 2n plus 10 minus 10. And we're left with 2n. And then the last step was to subtract the original number. So we take the answer we had for 4, 2n, and subtract the original n. If you haven't done a lot of simplifying of expressions in a while, you may be kind of confused on how to simplify these. There's a coefficient before n. If we don't write it, we assume that that's 1n. So if I have 2 n's and take away 1, I'm left with 1n, which is the original number. 1n is the same as n, And that's back to the original number where we started. All right, let's move on to page 448. It says, describe why this is different from the specific calculations we did with the 5 that we did earlier, and why it actually proves that it will always be the original number. The main reason is because n can be any number. N represents any number. We didn't put any conditions on n. It can be anything. It can be a decimal, it can be a fraction, it can be a negative number, it can be any number in the world. So that proves that it works for all numbers. All right. So they're going to walk us back looking at the justice problem just a little bit. This is towards the middle of page 448. It says, this is an example of deductive reasoning because we can use a general calculation to draw a conclusion, not specific examples. Let's see if we can do that with the handshake problem too. Pretend that you're one of the 9 justices. So I'm a justice. There's 8 other people I have to shake hands to. So I have to shake 8 hands. My friend over here is another justice. How many hands does that person have to shake? Well, that person also has to shake 8 hands. So if we extend that, we'll see that every justice has to shake 8 hands. How many handshakes is that in total? Well, add up 8 plus 8 plus 8 plus 8, 9 times. Or we can do this multiplication. We're adding 8 9 times. You're welcome to do that in your calculator. 8 times 9 is 72. At the top of page 449, you're going to say, wait a second, that doesn't match the answer we got in the table before. The answer we got in the table before was 36. This is twice as big as it should be. Why? If you remember when we did the drawing, when we went from person 1 to person 2, that meant person 2 already shook hands with person 1. So by doing it the way we've just done it here, we've counted them twice. Counted all handshakes. Oops, that is the right letter. I write math much better than I write words. So what do you think we can do to compensate for the fact that we counted them all twice? Well, at number 11, they tell me, just divide by 2. So the number of handshakes needed for 9 justices is 9 times 8 divided by 2. They want us to write a general formula with a variable n that we could use to describe the handshakes. And then we're going to actually do an example. We're going to just plug these numbers in and make sure they work. So with n was the number of justices we had. So that's going to be n. In the example we did, we had 9 justices. How many handshakes did we have? We had 8. 8 is 1 less than 9. So however many justices or people I have, I'm going to have to subtract 1 from that. So the number of people times the number of people minus 1 divided by, remember we did before, we counted everyone twice, so we had to divide by 2. And if we look back at one of our table, from page 444, let's verify one of those. Let's do it for 5 people. I know from the table that 5 people should have 10 handshakes. Let's see if the formula works. 5 times, what's 5 minus 1? 4 divided by 2. 5 times 4 is 20 divided by 2, which gives me 10. That makes me excited. I got the right answer. I'm pretty confident that my formula is correct. All right, we have just a couple more problems left in the very last section of our work. To wrap up our inductive and deductive study, to decide if the type of reasoning is inductive or deductive. So after failing the first 2 tests in a math class, John decided to start doing the homework regularly. Is that inductive or deductive? That's going to be inductive. He's going based on how he was doing in the class. Inductive He's using his previous examples. Because there's a chance he will still start doing the homework and still not pass the tests. Marlene was having a hard time keeping up with minimum payments on her credit card. So she started to make a budget to make sure she would not spend more money than she was making. That one's deductive. And the reason it's deductive is because it's a known fact that if you spend less money than you're making, you won't go broke. So, or if you spend more money than you're making. So it's a known fact that spending more than you make I'll scroll this up a little bit because I'm having trouble writing at the bottom page. More than you make will make you run out of money. So you spend more than you make, you'll run out of money. All right, top of page 450, the last two problems. Number 14 says, in spite of his friends' pleas, Jaden tried to drive home after drinking too much. None of them were surprised when he got busted for a DUI. Was their reasoning inductive or deductive? This one's deductive. And the author argues that it's deductive because the law and common sense tell you that if you drive while intoxicated, you're likely to get a DUI. 15 is kind of a cool one. My favorite professional team started off the new season 12-0, so I'm pretty sure they're going to make the playoffs. Depends on what sport we're looking at. So we're going to say this one could be either. And he gives a great example in the text. If it's a baseball team, baseball teams play roughly 162 games, so 12 is nothing. So we really can't say for sure if they're going to make the playoffs. If it's football, if you go 12-0, it's pretty likely you're going to make the playoffs. So next you'll go back to your group work and work on a little more with deductive and inductive reasoning. And I hope you enjoyed it, and I hope you have a wonderful day.